Welcome one and all. Today I will be taking you through the journey of chemo. Chemo here is a normal cell on its way to becoming a cancer cell. In order to become a cancer cell, chemo must acquire 6 characteristics known as hallmarks. First, chemo must become self-sufficient in growth, and here we use apples as growth factors. As shown here, chemo and his friends each receive 1 apple each. One mechanism that chemo can use in order to gain more apples is the upregulation of growth factor receptors. This makes him hypersensitive to the otherwise limited number of growth factors. Another method is the cancer cell's ability to produce its own growth factors that work in an autocrine fashion. Next, chemo must become insensitive to anti-growth signals. Here we have TP53, our prison shark, and normally if he sensed any damage he would arrest chemo in his cell cycle growth. This would allow time for repair or apoptosis to take place. However, if TP53 becomes mutated, it cannot do its job and chemo's proliferation can continue. So chemo is a damaged cell and must evade apoptosis in order to live out his life. In order to do this, chemo makes some new friends in the form of BCL2. These little guys are anti-apoptotic and protect chemo from TP53 and the thug caspase. After this, chemo might want to pack his things and find a new home. To do this, he can either invade the tissue next to him or escape into the blood. Chemo can then use the bloodstream much like turtles use the ocean currents and find distant sites. Chemo will then find a new tissue to which he will attach and colonize. In order to live forever, chemo must now develop limitless replicator's potential. Normally, cells only have a definitive amount of replications, and over time the telomeres begin to shorten, which would eventually lead to apoptosis. But in this case, telomerase comes to chemo's rescue and lengthens his telomeres, and thus deceiving TP53 the prison shark. Finally, chemo needs access to nutrients in order to continue his survival. Angiogenesis is stimulated by hypoxia, which upregulates VEGF. This in turn increases the expression of genes involved in the production of blood vessels, which will then supply the nutrients to chemo. And now, chemo can live happily as a cancer cell.